Hello everyone, I'm Ahmed Amirul Arefin, Department of Electrical and Electronic Engineering, University Technology Petronas. My presentation topic is determining islanding operation using microgrid phasor measurement unit parameters. So in this presentation, first we will discuss about the introduction, then the literature review, then we will discuss about the methodology, result discussions, and after that the summary of the presentation. So the introduction is that uh, the islanding is a situation when a portion of the power system where it includes basically the generation and the loads which isolated from the main system but it stay energized. So basically it's a special types of open circuit fault where the distribution resources continues to feed the local loads during the loss of main situation. The main disadvantage of the islanding are the mainly safety hazards, utility workers and customers. Also equipments are exposed to damage. For islanding detection, SCADA system is unable to respond accurately due to communication delay, and also SCADA system require higher investment to implementation. And there was a comprehensive survey on PMU application where they have been found that islanding detection for PMU could be uh, a significant supplication. So the literature review. So those literature are covered single level detection where they have considered only one PMU parameters, and the major limitation is the reliability issue. And those literatures basically cover the multi-level islanding detection where they have considered more than one parameters, and the major limitation is basically accommodating missing PMU's data. So here the literature review. So first these two references uh, covered the PMU's parameter of phase angle and frequency, and their main contribution is that their scheme is able to detect very fastly without any false trigger, and they have ensured the higher reliability by accommodating the missing PMU's data. But the limitation is that the scheme has been collapsed to detect when the phase angle and frequency are well matched during the islanding event. These two literature considered the voltage angle and frequency components from PMU for the islanding detection, and they have successfully lessened the false trigger during the islanding event. But the limitation is that the computational time is higher. These two literature 11 and 12 they have considered positive sequence power using the voltage magnitude and the current magnitude to detect the islanding event, and they have successfully uh, done the improvised detection time by no false trigger, and they have also some major limitations where the completing time is higher, and also they didn't consider the missing PMU's value, so they have didn't consider the higher reliability also. This 13 reference number reference considered voltage angle and current angle of the PMU parameter for the islanding detection, and the detection time is faster. But there was some false trigger when it goes to several attempts, and also some inappropriate thresholds make it some false trigger. These last two references basically consider the phasor and the frequency components of the PMU for islanding detection, and they have reduced the false alarm, but the higher completing time and less reliable due to unpredictable, undetectable missing PMU's sampling data. So here's the methodology for our research is that first we will design the network, and we have to define the slack bus, yeah, from our microgrid system. Then we have to create some different level of distribution. For this, we have to define where the transformers, where the distribution transformers are. It means that where is the transformer between the transmission and the distribution. So you have to find out those transformer from your microgrid, and then you have to try to make up a setup, different combination for the transformer. And in this case we have said that at a time only two transformer can operate, and rest of the transformer will remain closed. So this is the transformer combination, distribution transformer combination for our uh, algorithm. Then for the islanding operation, you can isolate generator or the load bus for the islanding. Then you have to do the power flow analysis for the simulation. Then for the phasor measurement unit, you have to consider the voltage angle data and the current angle data from the PMU. So this is the flowchart and the algorithm of our methodology. So this is the phasor measurement unit, where we will have voltage angle and current angle data before islanding and after islanding, and we will compare that data to the thresholds, and if it's greater than thresholds, then we will take it as a islanding operation, and if it is less than, uh, then we will take it as a normal operation. So this is the uh, simulation part with what we have done with the IEEE 30 bus, where we have done the full Newton power flow study, and for isolation, for islanding, we have isolated the bus number 32 from the main grid. So here are some results, and some results are showing that this these data are showing that before and after islanding scenario. So you can see that this is the bus number 1, where the voltage angle remained same, because this bus number 1 is slack bus. So voltage angle didn't change, but the current angle changed. And also, if you look at other buses, you will definitely see that the angles are changing before and after islanding, which is really not expecting for us, because we need to make the system stable during the islanding and before the islanding. So those are the datas of each and every buses before islanding and after islanding data, and all the datas are showing that there are some unstable situation when the microgrid goes to the islanding. So the main issue is that here we are discussing about the 132 kV nominal buses, and we have shown that the voltage angle and current angle by some web plot waveform plots. And here the in the plots, the red plots are showing the uh, islanding event, and blue plots are showing the normal after islanding event. Before islanding events are showing by the red forms, and after islanding events are showing by the blue one. So here the waveforms are describing some significant changes when grid goes to the islanding operation for a certain period, and this islanding have been detected from the waveforms after performing power flow study. So if we give some shadow on the bus number 1, we can see that this bus has no change, since this is the slack bus. So here the voltage angle remain unchanged during the islanding and before the islanding event. So for the power network, it is always required to maintain a stable and unchanged situation. But when an islanding event operates, it is always challenging task. But setting the threshold precisely, then we can prevent system from the islanding event. So this methodology can appropriately determine the islanding event, and the comparative study also shows some incredible changes in phasor measurement unit parameters when our grid goes to the islanding operation. So this simple islanding determination scheme can be very applicable for some private microgrids like factory, hospitals and office buildings. So those are the references. Thank you.